Hello, Internet, and thank you very much for joining us on the cloudnative.fm podcast. And today we are talking about regclient and the Open Container Initiative. And let me just define what the Open Container Initiative is. Open Container Initiative was launched in August in 2015 with the goal of developing common, minimal, open standard and specification around container technology without the fear of lock-in. OCI has been evolved over the year tremendously. That it's basically like container image format and runtime specification, which enable a consistent and stable platform for running containerized application. And I am very happy today because I am joined by Brendan Michaud, the author of the Reg Client, and he's been a very good maintainer of the OCI format as well. Thank you very much, Brendan. And he's also the Docker captain, so it's been a great talking to you today. Thank you.
Thank you. Great talking to you as well. And I think you really nailed it with hitting about the OCI and how they've been trying to standardize a lot of this. And I think it's a layer below what a lot of people understand. They know they run the Docker build, they create the image, they ship it off and it goes somewhere. And so a lot of what we've been doing is the nuts and bolts underneath the covers of what people usually see, but we're trying to extend it for some features that we're looking at to add on in the future.
Yes, absolutely, absolutely. And I think the container initiative is actually, I remember back in 2015, might be DockerCon 2 or 3, or is DockerCon 2 might be in the June of 2022, 2015. And I think the Docker donated one of his project, uh, one of his project called Container D to the Open Container Initiative. And I think that's the first step was to make this organization who is making sure that the standards are met because there are so many ways to build image, to run the images and build the container out of it. So can you circle back how all the things happening at that time and why people realize why we need a OCI and how many people working there back in 2015?
Yeah, 2015 was just shortly before I jumped into a bunch of this, but Docker saw a lot of that need. They were getting pressure somewhat from the community as well, but I think they were very much in the open mindset of we're creating this thing that's bigger than us. We need to make sure that we can have this interoperability because they didn't want to be the only one that was building containers. They didn't want to be the only one that was running containers. And so they pushed out standards like runc. And so runc is an OCI project itself. That's running the lowest level of what the container is. And then on top of that, you have container D that's managing the images and the different file system layers and packaging all those together. They forked that off a while back as well. And another one of the big projects they pushed out there was the registry itself, distribution. And so it was under Docker/distribution. And that got moved off. I believe that was in probably the last year or so. They pushed that off as a CNCF project as well. So now that's being maintained by the community. And so you have these multiple pieces of the project that were really started by Docker and that they've now since pushed out, open sourced, always open source, but putting under the community management. So under OCI, under CNCF, so that we can get some interoperability in there, but also have those nice reference projects people can look at and use.
Yes, absolutely, absolutely. And one of the I really like about your project as well because we have Docker Hub, Container Registry, or so many of them as of today. But we started with Docker Hub. We all know we have only one registry where you can upload the images and pull the images. But as of today, we have GitHub Container Registry, ECR. Amazon has its own. Microsoft Azure has its own GCR. So many registries are there. But one of the I like about your project that Reg client is you can interact with the registry using a command line. So when you think about this idea, and what was you thinking in your mind? Why we have these kind of flexibilities in the terminal?
So a lot of the Docker command line, when we're looking at that command line, you say Docker running this stuff, it's all based off of what is pulled locally to your Docker engine. And the big question a lot of people have when they do that push and it's up on a registry is, okay, what is up on that registry? How do I interact with it? How do I query what's there? And so they have this content that they just didn't have the command line access to see. And so there are a few tools out there. There was Scopio that was being pushed by Red Hat. Google had a project called Crane that I hadn't even seen before I started this up. And so I said, let me make something that can be nicely integrated with Docker that would play nicely with a lot of the Docker tooling that was out there. And so I started creating it, and it just kind of spun a little bit. And so I have some slides if people want to see a little bit of what is some of these command lines, what the response is and what it looks like. We can jump into that if you'd like to.
Yes, yes, absolutely, absolutely. Do please share that.
Okay, let me pull this up. All right, is that coming through? Perfect. So if you run this, if you've never seen a container image before, what you'll get is there are a couple different key components of it, and they get shipped as different parts. We've got blobs out there, and I'm pulling this big long digest, and you're going to see something that looks very familiar to what a lot of people recognize when they run a container. You've got like the created date, the architecture this is, and then you start to see this stuff like the environment variables, the command you're running, the working directory. And if you've ever done a Docker history on image, you'll see a bunch of these lines at the bottom where I had to crop it off just in front of the screen, where it's like adding a layer, setting a label, all these different things. This is all shipped up to the registry in a JSON blob. So that's like piece number one that people would recognize a little bit. And the second piece people usually hear about are these file system layers. And they've always been told, an image consists of a bunch of these layers. So again, I'm going to pull that as a blob. And instead of running it through JQ to make it nice Java formatting, since this is, or JSON formatting, since this is a tar file, I'm just going to run it through a tar command. And this will go on for a long while. I'm just going to show the first few lines of this, where you can see the file system showing up here, each individual piece. And so we have these two pieces that make up what people tend to think of as an image. And now we need to assemble these two things together. And so the registry, the way it does it, is we package another little bit of JSON, which is called a manifest. And so when I run these commands, I say regctl manifest get instead of blob get. And I query and I say, grab the one for this Golang image that I've got, pull the individual platform, and I say, show me the raw JSON format here. Because normally I do some pretty formatting. So if I don't override that formatting, you don't see that. And what you see in this is the config is there and the layers are there. And we've got an array of these layers. So we'll have multiple layers that make up an image, and it'll assemble them all together. But these digests here are the digests we were looking at earlier. And so when you go query this manifest and say, give me the manifest, you can go pull this up. This little piece right here, when the config is pointing to this bit of data, this is called a descriptor. And so the descriptor has a media type, the size of what it's looking at, and the digest. And that uniquely defines a piece of data that's on the registry. You can't change that. If you ever change it, that digest changes because that's the digest of the content. And we do the same thing for layers, just an array of these descriptors. And so you have one or more of these things. And that's what you're going to get out of having one of these images out there, is you're going to have this little structure so far. And what we added not too long after that was we said, well, we need multi-platform images. We don't just want one image from one platform. So they had one layer above this. And the layer above it it's going to be a manifest list, is what it is in the Docker term. In the OCI term, it's an index. And so I'll call it an index here at the top. But in this case, if you really looked under the covers, this is the Docker format. All these media types here are the Docker media types. And so this is it's an array of manifests, just a set of them. And so you'll have the one here for AMD 64. You'll have another one here for ARM V8. So if you had your Mac M1 and you had your Intel x86, when the client that you're running queries a registry and says, give me this image, it's going to get this first. And then it's going to look through this list and say, well, I want that manifest for my platform. It's going to pull that one. And it's going to see, okay, here's my config, here are my layers. Let me pull those things. And that's how we ship an image. That's what's going on in OCI under the covers. So far, so good. Making sense? Feel free to throw questions out in the comments as well. And stop.
Yes, absolutely, absolutely. Wonderful. Like one question, we have a Bujahan, one of my friend is also on the chat, and he's saying the same word, like Brendan is a role model of the container ecosystem. And that's absolutely true because he's has so much wonderful knowledge about container as well. And one question, like, do in a regclient, we still have the policy engine in place in the container ecosystem that restricts to do some of the stuff. So if we are using regclient, do you see what are the information can policy engine use by using the regclient to make some decisions in the Kubernetes pod on the Docker container?
Yeah, this is going to be a few layers below the policy engine. So you'll have your policy engine that says what I want to run. We'll get later on into this. I'll show you what we're going to start pushing up into the registry and what the policy engines can start to use to make their decisions, because that's going to be key when we get later on in this discussion of how we can start looking at like the SBOMs, the signatures, that kind of stuff. Because right now we haven't even gotten there yet. We just have, this is like the 101 of a registry of, we just shipped an image, and people want a lot more than that these days. I did kind of skim over a little bit. We kind of talked, and I showed you these little SHAs and these digests here. Everything in a registry is content addressable. So every time I go out and push this manifest up to the registry, and I see this digest out there, and if I query and say, give me this digest back from the registry, if I query that raw content and ran it through a SHA-256 sum command, hard to say that when it's early in the morning, what I'm going to get back is that exact same digest. So the digest of the content that I'm querying is that same, it's the digest of the content. It's that same field there. So you can't change this blob on the registry without changing the digest. And so that's how we get that assurance that nothing ever got modified. And in addition to that, let me show it up as a picture here on the screen. We put the digest of the config, we put the digest of each one of these layers in there. Those digests are all represented in the manifest for the image. And then that digest for the manifest of the image is represented inside of this index. And so when you query this tag, you've got the digest of the index. That means that none of this content anywhere in here could have changed. It's, if you've ever seen a Merkle tree, something like that, that's what we have built under the covers here, is effectively very similar to a Merkle tree. But the data structures for each one of these things, you know, you'll have a unique piece of data in here. So it's not quite 100% Merkle tree. The other thing we've got is the term people use is a DAG. It's a directed acyclic graph, which means you always start at one point and you can go through this, but you can never have loops. You can never go back on yourself or anything like that. And so that's a very important structure when we start setting up a registry, and that comes in to bite us later on if we ever wanted to make too many changes. And so between those two things, this is kind of what we've created as our image on the registry. And an important detail to remember here is that the registry itself cares about these index things and these manifest things, anything that is a manifest, that top level JSON. But once we get into those blob pull commands, registry doesn't care at all what's in that blob. All it cares is that the content matches the digest on that content. So you can put whatever you want in this layer, you can put whatever you want in this config, and the registry does not care. And so that's completely free form to us. There are some registries that will say, what's in this manifest? There are some restrictions in there. They'll say, make sure there's only got certain types of fields. They'll do some validation. But that's specific to individual registries. But what I want to dig into is, because we can put anything in there, because we can change that content to whatever we want, what we've seen is that we can push arbitrary data up there. And some of that arbitrary data we've already been seeing. So like I say, the manifests have to have their known media type, but you can have Helm charts that we pushed up to a registry. You can have the cosine signatures. Those are pushed up to a registry. Flux CD, I saw them just recently announced they're going to allow you to start pushing the Flux metadata up to a registry. That came out just in the V032 release they were just pushing. So all of these things that are going out, we've got this stuff that can go up to a registry as it's just a manifest and with a config and some layers. So if I go out and grab this Helm chart and query this from a registry, the manifest looks very similar before because it's the same media type. We have to stay within that structure with the config and the layers. But we've changed the media type here on the config. We've said instead of this being an OCI or a Docker config, this is this Helm config here. And it's got this digest. It's got a layer in here. The layer itself, instead of being just normal tar or TGZ, it's now this Helm chart content media type. So they've changed the media types. And as long as the registry isn't filtering on those, you can push this up to any registry. Some do, some don't. But as far as we're concerned within OCI, what the thing we care about is that the digest matches. And so when you extract that and you go into these blobs, I can pull this blob and look at the digest there for that first config, and it's just a little bit of JSON. It says, here's the Helm chart I pushed. This isn't an image at all. It's just pushed up to the registry that looks like an image. And the same thing for that layer in there. It's a blob. It was a tar blob, but this isn't a tar for a file system where you can run executables in there. This is a tar file for a bunch of Helm data for YAML files that are going in and being parsed by the Helm input. And it didn't have to be a tar. Could have been anything in here. Could have put a JPEG in there. You could have put your SBOM in there, a bunch of JSON, whatever you want to put in here, we can set in this content that we want to. And so that's kind of where we've been going through. And then OCI made a working group. And the reason we made a working group is we were starting to look at some of the challenges people were having And the output of that working group just got merged last week. So it's very timely that we're talking about this now. And at least it got merged into main. We haven't tagged it yet. So it's not quite like a finished standard, but getting anything merged into main on OCI is like a Herculean effort. So there was some champagne bottles being popped last week, I think. And so what was the working group doing? I'm building it up here, but we're looking at all these artifacts, and the artifacts out there, they are referencing an image. They're not just the standalone Helm chart. They are things that are like the signature, like the SBOM. Those are the two big examples where they're saying, I have an artifact that I'm pushed up there, but I'm extending this other image. And what we wanted to figure out is how can we make that relationship between the artifact and the image that is extending? And so how do we make that relationship? Well, we've got things like these, the signatures that we want to have for stuff like that. We've got all this detail in there we want to include. Importantly in there, we don't want to change the digest of our image. If we change that digest, everybody's downstream, you probably heard a bunch of times, we're pinning our images. And the idea of pinning your images, you know that when you've got that digest on that image, it hasn't changed, whether it's on one registry or another registry, wherever it's moved around to, it's that same content. We get that assurance. That's our security thing. So you can't start putting this extra metadata into the image itself, because once you do that, you're going to change the digest. And so we need to find a way to externally inject this thing with relationships so that we can say this image here has gotten extended with this other bit of metadata, but how do we make that relationship? And so we had a couple goals. We were looking at how can we do this with some new metadata? So it's not necessarily the image originator is going to do it. It could be a downstream user. You could be a company that ingests a bunch of open source software into your company registry, and maybe you want to re-sign it with your company signature. Maybe you want to run your own company SBOM scanner because you're expecting it in a different format than what upstream did. And so we're assuming if the image originator isn't going to put all the metadata on an image, someone else might want to add it later on in their own environment. We're also looking at how can we copy this stuff around? Like I'm saying, you're going to have these images that are upstream one place. I've talked to companies that are saying, hey, we want to mirror this stuff out into the field where it's going to be, think of like a fast food chain or something like that, where they've got thousands of locations and they want this stuff to be able to run within the organization when the network goes down. Or if you're thinking of utilities where they've got equipment out in the field, they want to be able to run during a natural disaster when it doesn't have that network connectivity. So we need to be able to mirror these images out to locations that might not have a stable internet connection. And we need to be able to find a specific artifact easily. So we mentioned things like signing. I've thought of a big example for signing for me is that it makes a nice way to decouple the vulnerability scanner from that emission controller we were talking about earlier. Because the emission controller today needs to know very much about how to talk to that vulnerability scanner to verify that we're scanning the right images. We get this tight coupling between those two components. And I thought it would be nice if we can say all the image vulnerability scanner needs to do is just output a signature saying I've signed this. I put my stamp of approval on there. And all the emission controller needs to know is how to validate that this image was signed with a valid signature that hadn't expired yet. And if you do that, if you decouple those two components like that, now you can plug and play. You can change your vulnerability scanner, you can change your emission controller, and those two pieces don't need to know about each other. They don't have to be tightly integrated because all they're depending on is that signature. If you do that though, you need to be able to keep this fresh. You're constantly rescanning images. So you might have hundreds of signatures on one image, and you might have 99 of them expired and only have 2 or 3 of them that are still valid from the last scan. We need a way to quickly look through that whole list and say, this is the signature I want to query out of that list. This is the one I want to look at without having to fetch every one of those signatures out there. So we're looking at that. How can we minimize the number of calls we're going back and forth with, and how can you find the artifact that you're looking for really, really easily? And the last complexity here we were looking at was backward compatibility, because we've got existing registry servers, we've got existing runtimes, and we don't want to break either one of those things. We don't want to put a change out there on the registry that's going to break existing Kubernetes clusters so they can't run the images anymore. That would be bad. We don't want people pushing images that look different to the registry, and so now nobody knows how to work with it. And we also want to figure out how can we do this and work with registries as they are today, maybe have a forward migration path where things look better in the future, but at least still have some kind of possibility that we can use an existing registry server today without having to change it at all. And so we're looking at all those different complexities in there. And so the answer we came out with was we're going to add a new field onto that image manifest. And you can add a new field in OCI. You can put it in there as JSON. So if something's parsing some JSON, it sees a field, doesn't recognize it, just doesn't parse it, just skips through. So we can add a new field on there. Anything that knows how to work with that field can work with it. Everybody doesn't recognize it, just ignores it. And that field is very different than the way OCI has made fields before. Usually we say this is the child of my manifest. And so I make a manifest and I've got a bunch of child objects, the layers, the configs, the blobs, and whatnot. This was kind of a reverse. This was saying I'm an artifact and my parent is this other image out there. And so I'm extending my parent. I'm referencing myself to my parent image from the child. So it's very much a reverse pointer. And so that's where you have to be careful when we're working with that directed acyclic graph that OCI is, that's under the covers. You have to make sure we're not making anything that can, create some cycles, do something weird in there. So we put this field on there, and this field is recognized by a new API we're creating. And so the new API is going to say, I pulled my image. Now tell me everything. Give me a list of all the different artifacts out there that have this refers field that is pointing to my image. And so you can query that API and it will give you a list of all these manifests that are out there that are pointing to your image. And so now you can look through that list. And from that, we've got this coming from OCI. In OCI, a list of manifests is just an OCI index. So we just reuse the same data type. That made it nice and easy for us. We got some reusability in there. And hopefully things got a little simpler from that. And then each entry in that list, we pulled up all the data that someone might need to know which artifact they want to get. And so we pulled up the type of artifact that we're looking at. We pulled up all the different annotations that were in the manifest that we're listing. We pulled that up into the list as well. So now when you get this list of all the artifacts that you're looking for, you've got all the metadata you need to know which item in that list you want to look at. So that was kind of the big thing we did. Another piece we did is we also added a new artifact manifest. People have been complaining about this for a while. We're saying everything out there is this image manifest, and we're not pushing images anymore. We're pushing artifacts up to the registry. So we made a new manifest. I'm thinking this is the nice future thing, because very much in a registry today, if you push a manifest and the registry doesn't recognize it, it's going to reject it. And so I don't see anybody using this very early on because they want that support of existing registry servers today, and it's going to take a while to get all those registry servers updated. But once we get that, we can use it. The things we changed, that little config descriptor out there, we took that out. But the media type on that config descriptor, that thing that was saying, hey, I'm a Helm config or something like that, we wanted that little media type to be recognized. And so we call it the artifact type. So we pulled that up into the manifest for the artifact. And then we changed the description. We previously said it's an ordered list of layers, and those layers have to be applied one after another in that strict order, and that's how you get a container image. We said, well, for an artifact, we're just going to call it a list of blobs, and whether or not it's ordered depends on what tool, what artifact type it is, and what tool it is. And so it's entirely up to the person that is building this artifact as to whether or not they need to be ordered in any way. And so we kind of deferred that decision off and said, at least from the OCI part, we don't care what order it is. So we created these two things. I think pictures kind of describe this a little better than words, though. So this is kind of the big key thing that we got here, which is we had our index before, and it pointed to a whole list of these manifests. And so I pulled out just one of them for this sample. And now we're going to create this new artifact. And so I'm calling it the current way we do the artifacts, which is with an image manifest. And so we still have that config and the different layers in there. But we add this new refers field. And so when we push this artifact up there, call it a signature, call it an SBOM, whatever it is you're pushing up to a registry server, we have this refers field, and that's going to point over to the digest of this image that we pulled. So now we pull this image, we can now say, who's got this refers? And similar to the new manifest that we're talking about, that artifact manifest, it's also got the refers field. But instead of having the config, it just has the artifact type that's pulled up as a field within the artifact manifest, and then an unordered list of blobs. Pick your blob, any blob. And now we need that way that we can do that query. So how do we say, once we get this image manifest, tell me all the metadata on it? Well, the thing we added was we got this refers API out there that you can query, and it's going to output a list of all the different things that have that refers field point to you. So that's kind of how we structure this thing so that we can get this stuff connected together. So far, so good. Making sense? I see a lot of nodding over there.
No, yes, wonderful. So, I think it's really easier to understand when you talk about when you show the diagram, because it's easier to just what's happening underneath the layer, because we all know the container has so many underneath layers, so much happening behind the scene. When you just when you push the images to the Docker Hub, when you pull the images from the Docker Hub, there is so much happening there. So it's easier for me, at least, to understand what's happening behind the scene and what's the aim was for the Edge client as well. As also.
Yeah, and I see a lot of people get confused. They see these digests all over the place, and they're like, well, I saw my layer digest, and so how do I associate that with this other thing, with that other thing? And And so sometimes it helps us see, okay, everything in here has a digest. It's all content addressable. And in fact, I'm skipping over some details. Some of these things have multiple digests, but I'm going to try to keep it somewhat simple just to get through what we're talking about today. But yeah, the index itself has a digest, the image has a digest. And so each one of these things you're querying is going through. And so you see those all over the place. So I want to hit on backward compatibility a little bit, because backward compatibility, we were talking about that registries, if they don't recognize that manifest, they're going to reject it. And so more than likely, it's going to be a while before we can start using that new artifact manifest. But also, we've got that new API, and it's going to be a while before registries support that new API that we're talking about. And so how do we do that? Well, we took, since we're using that OCI index, which is a known manifest, a known media type that we're putting that list in, so instead of having the registry server generate that on the fly from that API call and return that to you, for an existing registry today, we're going to push that workload off to the clients and have the client build that index, push that up to the registry for us. And so instead of having this thing here generated from this API call, we're just going to create a well-known tag up on the registry. And that well-known tag is going to point over to this. And whenever a client says, I'm adding this new manifest over there, it's going to pull this down. It's going to update. It's going to push a new one up there under that well-known tag, so that other clients, when they query the registry and say, hey, I don't see the API out there, let me fall back to look in this tag, they get that exact same response back. So there's no question of, changing anything one way or another. It was a nice thing about reusing that same data type. We had that exact same content we can reuse in both places. And so all the downstream programming gets very simple because it's the same response we're getting back from each of those. So that's what we're creating. Some people might say, well, hey, if you're able to do this on existing registry, why create that new API at all? There's some challenges. There are things like race conditions. I've seen people that complain when they start pushing up a lot of multi-platform images that sometimes the one platform overwrites the other platform. They're both conflicting on trying to update that index simultaneously. There's potential for bad clients out there. And one of the big things I've seen is garbage collection, where you delete the image, but now you need to know that you can go out and delete all these artifacts that refer to that image. And if it's separately tagged, the registry doesn't know that. It's going to keep it around for indefinitely. And so having some of that logic built into there, it's nice to have that API doing all this for us. So let's tie this in with the container security. I mentioned that this is what we're looking at with signatures and SBOMs. So we've got these two key pieces that are what we're storing up on the registry. When you copy that across from one registry to another, it's very nice. We can copy that signature, copy that SBOM from one registry to another. If you've worked with Docker Content Trust and the original Notary project, you might know that that was a separate server that was implementing all that signature data, and it was tightly tied to the image name. So if you ever retagged an image, if you ever moved it to another registry, you lost your sign data. You didn't have that. It was no longer signed. And so as we're looking toward the future and we start doing this stuff, we're looking at how can we move this data with the image around so we can replicate that out into the field. So we can use this in a disconnected piece of utility infrastructure during a natural disaster. And it's not going to say, yep, I can't hit the internet. I can't verify this thing. So it's not signed. So I'm not going to run it. That's not good during a natural disaster. We want to have this stuff running in a disconnected environment. And the big thing here is we're able to push that stuff without ever changing that digest, that original manifest of that original image, and that we can start putting other kinds of metadata in here. I'm looking at this of, signatures and SBOMs are big, but I think before the call we were chatting, Saeem, and I was mentioning I was doing some reproducibility stuff where I'm capturing all the different network requests, all the HTTP requests of a container image build, and I'm capturing all that data. I can push that up to the registry alongside my image. And that's just another artifact that is associated with my image. And now I can go through and ship that with the image. And anyone else that wants to verify this was built reproducibly can pull down not just the image, not just the package repo that I built it from, but all the network requests that I used to build this and verify that, okay, nothing changed in the process there. Because if you're ever doing a normal image build with like a Docker file with a run command in there, it's going out grabbing mutable stuff all the time. And so I was looking for a way I can change that. So this ties in huge with container security. I think, we've seen a lot of slides. Everybody wants to see a demo. But before I do that, I'm going to throw in my little add in here, which it's an open source project. So no money is changing hands. But I did mention you've chatted about, and I've seen the link thrown up there for the regclient project, where it is a Go library that is able to interact with registry servers as a client. So anybody who wants to write a client can write against this. I've had a few other people I've seen go out there and make this for just pushing up their small manifest, whatever they want to do up to a registry server. That exists out there. Now within this, I've got 3 different binaries that I'm shipping. And the first one was kind of the big one that I made back when Docker Hub announced their rate limits. I think a lot of people saw that and were like, oh no, Docker Hub's rate limiting everything. I don't know how I'm going to do my CI platform anymore. And I said, well, let me make a nice, easy tool out there, because originally, if you copy an image, if you did just like the Docker pull, Docker push, you're dereferencing that platform. So now when you pull it down, you're pulling it down to your local platform, whatever your local Docker engine is. When you push it, it's not the same image that was on your source registry if you had a multi-platform image. It's only the one platform that you just pushed. And so I was looking at how can I do this in a nicer, more efficient way, especially for CI environments when you have like the ephemeral builders. They don't necessarily have that image cached the whole time. You don't want to pull down the whole image if you don't have anything updated when you're getting ready to repush it. So I made this little regsync project that's just, you pass a YAML file, and from that YAML file, it's going to update a bunch of, it's basically going to maintain a mirror for you. And so you spin that up. So that was project number 1. Project number 2, as I said, well, once I create the mirror, people immediately say, well, how do I clean up the mirror? As soon as I start building up images and start filling up the file system, people want to start pruning those old images after a while. Don't know why, apparently, hard drives fill up, but yeah, that is important to fix. And so I looked at how we can solve this, and I said, there is no way I can make a policy that's going to work for everybody for image retention, because everybody I've ever seen has a different image retention policy. Some people have tags that mean different things. Some people have tags that are released to production and they want to maintain anything that goes out to production for 5 years. But how they define that is different for every organization I've ever seen. And so I just said, I give up. I'm not going to be able to solve this. Let me just give you a scripting language you can put on top of it. So it's got Lua under the covers if you've ever done scripting with that. And it just has all the API calls from regclient tied into Lua. And so you can write whatever you want to and do this. There's still some UX work that needs to be done over there, but that exists for just setting up some more retention policies. But the one you've seen in the demos today has been the regctl project. And so this is just a CLI directly to a lot of the regclient APIs. There are a few things that it does on top of what regclient provides, but for the most part, it's just calling these regclient APIs. And you've seen well, before I jump into that, I ship it in a couple different ways. All these binaries are shipped as either a binary or container. I also threw out a GitHub action for regctl because I feel like I've run into enough use cases myself where I said I wanted to throw this into a CI pipeline. So I'm shifting it like that as well. And so you've seen me query a registry. So I've done that little manifest git, the blob git commands. Those give you a nice way you can query the registry. You can also list the tags out there. If it's like the distribution registry, you can run standalone on yourself. You can run a list of all the different repositories on the registry. That particular API call is disabled on most cloud instances because typically a cloud environment doesn't want you listing all the competitor registries as well, and they don't want to try to figure that all out. So they just turn that API completely off. But we've got that kind of querying stuff out there. We've got the copying. And so if I ever want to copy or retag an image, that just exists out there. You say image copy, the old name, the new name. And if it's in the same repo, that's super quick because all you're just doing is a retag. We've got out there this export import. Mentioned I've been in environments where you have to worry about the air gap or the production infrastructure doesn't necessarily have access to the internet. And so we need to pull down image to the file system, sneakernet across to the secure environment, and then re-import into the registry over there. This handles that for you. The deleting the tags is kind of a big one because normally you can delete a manifest, and that API is enabled for some registries. There is an OCI call to delete a tag, but most registries don't support because that was never in the Docker spec for the registry. That got added late into the OCI spec where they said, okay, people might want this. So you don't see this API enabled in a lot of registries to delete a tag. And so what I do is I try the OCI call to see if I can delete the tag. If it doesn't exist, I push a manifest out there. That's just like a little temporary fake manifest to overwrite the tag with a new digest for a new manifest. And I can delete that. And so that gives me a way to delete a tag without deleting all the other things that point to that same original manifest. So if you had your RC-1 tag that you don't want to sit out there forever, but you release that as like the V1, if you ever go out there and say, well, I want to delete the RC1, you don't want to delete all your other images out there that have that same exact manifest. And so the ability to delete a tag was kind of big for different people, different use cases. And what I'll show off today is I'll show what it looks like to modify an image. Because I think that's kind of cool is I can modify an image out there. Of course, when you modify an image, you're going to change the tag. But I want to show kind of the abilities of what that looks like. And I also want to show off what it looks like when we start to work with these new artifact calls, the push and the pull and a list of the APIs for artifacts. I want to show what some of that looks like. So I figure we can jump into a demo. How do you think about that? Sound good?
Yes, absolutely, absolutely.
Let's dig into some of this stuff. I'm going to actually go off script because normally I've got this thing sitting out there with a screen that I can just record and replay. But I'm just going to actually kick these commands off because sometimes it's fun to actually sit back and run this. So I was originally doing with regsync. Let me go with regctl. I got one image out there for that. I'm going to also do another image out here, or that's the cloud image. I'm going to have this on my local environment. And so it's going to be on the local registry. I'm going to run these commands. To be able to run this, let me set this one last variable here. So now I can start kicking commands off. I've got a couple variables set. If I show you what I've got in my local repository right here, I don't have much. I've got an Alpine image, an Edge image, an Edge Alpine, the latest. So a couple things. I picked this example because I kept that repo clean just for this demo here. And I mentioned that I can copy images around. And so if I go from that cloud instance to my local instance, I'm going to kick this off. Hopefully I don't kill the bandwidth too much. Fortunately, I think I've got a lot of these layers already. And so that was relatively quick. And so now I've got this image copied to my local environment. And we've seen I've done this manifest get command. Let me show this off. If I run this manifest get, we're going to see, first I kind of pretty format stuff normally when you run it. So you'll see me do the --s format body a lot to get the raw JSON. Sometimes it's nice just to have it formatted nicely to view it easily. So I got the name where it's in my local machine. It's the Edge Alpine image. You can see this got the Docker media types. You can see the digest. This is the digest of that manifest list itself. You can see the individual platforms in there. And so I've got the 386, the ARMS, AMD 64, the ARM 64, a whole bunch of different platforms out there. This image is built for just about everybody. And now if I wanted to look at a specific platform, I'm going to run this and show you just what one platform looks like, which I pulled it out. In fact, I should have shown that command a little bit. Let me show you the command so you'll see what I'm running. I'm kicking off the manifest get, but I'm saying, give me the one platform out of there, and I'm going to format it with the JSON. So I'm going to run this through JQ. So when I run that, now I'm going to see the actual raw manifest for my one platform. This is back to those layers in the config that we were seeing before. So we got all this data out here. Importantly, what you don't see is, well, two things. One, all the Docker media types. And two, we don't have any annotations here. What I do have in that image, if I kick this command off, if I look at this, I'm going to pull the image config again from my one platform. What I do have is a bunch of labels. So I've got all these labels. These are normally thought of as annotations in the OCI world, but we've set as labels inside the image config. Same kind of value, but it's stored in a different place. And depending on the tool you're using to read this stuff, they may want to see this as an annotation on the manifest, not as a label in the config. So how we store this data is important depending on how we want to use it. But otherwise, again, we're looking at the same data that you're probably used to whenever you look at an image out there and you say Docker image inspect. This is what you're used to seeing if you ever inspect an image. So we got all this. Again, all the history is out there in that config. So all that is there. And what I want to show now is that we can do some modding. Because this is kind of the first demo is how do we modify this image? And the mod command, it's still experimental. I'm still sorting out, do I want to change this too much? But I've got a bunch of different options here. First things I'm going to point out is I can either create a new tag or I can replace the existing tag. I wish I could kind of order some of these things and group some of these options here. These kind of all get nested all over the place. So what I'm going to do is I'm going to create a new tag because I want to modify my existing tag and break some other use cases out there. The other thing I want to do is I want to take all those labels and move those annotations. And I want to also take the, the media types and convert them all to OCI media types. Because technically, an annotation is only on the OCI media types. It's not on the Docker media types. You can do bad things like me and actually allow it to be on the Docker media type, but it's officially not there from Docker. For this command I'm going to run, I'm going to say run this image mod command. I'm going to do the create of a mod tag. So it's going to make a tag in the same repo. I'm going to convert OCI and I'm going to say change those labels to annotations. And when I do that, it comes back super quick. It says, okay, I'm all done. And so if you're paying attention earlier to those digest, if we were to query that same manifest get command that we were looking at before, but now looking at the mod tag, you would know that all these digests changed when we did this. Importantly, all the media types changed. And so it's now an image index from OCI. It's now an image manifest from OCI and all these media types. So all those media types changed. We don't have at this level any of the annotations because those are down the platform level. So let me run again that command we were looking at earlier. We were saying, let me get the different fields here. Again, all the media types changed to OCI, but now importantly, if I scroll down to the bottom, all those annotations got pulled up. So now we have the annotations inside the image manifest, and we have this data we need up here. So we've got that. The config itself pretty much unchanged, so I won't even look at that. But now that we've got this, let me do change the image that I'm working with. I'm going to change the image to say that instead of working with the original edge, I'm going to work with the mod image. And let's do some fun with some artifact stuff. So that was kind of the first half, was let's mutate the image. And I've used the mutating the image for a lot more than just this. I've done some of my reproducibility stuff. You might have seen like the image mod command had some timestamp stuff in there. I'll go through and strip out the timestamps from all the configs. Not only that, I'll strip out the timestamps from all the file system layers and move those timestamps back to a certain date. So I'll do my builds and say, make the build look as if it happened at the exact same time the git commit happened. And that way I don't muck around with my base image because the base image will have existed prior to the git commit happening. But all the stuff that I add on top of that base image will get backdated to whenever that git commit happened. And so I can get that nice consistency there where I don't mutate the base image, which is nice not to do, but I do mutate the image that I created. So let me do some syft commands here. If you ever played around with syft, they've got a nice, easy way to generate some of these SBOMs. And so I'm going to kick this off for a couple of these commands here, where I've got a SBOM. I'm going to convert to cyclone DX. It's going to give me a couple warnings, but nothing too major. And let me do one last one here where I say, let me do it to SPDX. And if you look at that, it's a bunch of JSON. But in here is just data about everything that we have done inside of my image. So you'll see a bunch of Docker libtrust stuff. I'm pulling in old versions of Docker where they had some of their security in there. I've got the Open Containers Go Digest. This is all the different libraries that I pulled in as part of my project. And since it was Alpine, if we scroll through this enough, you'll probably see some Alpine things as well. So we've got this. Again, the tags, if we were to look at that tag again, just sure there's nothing up my sleeve. The only thing we've added was this mod tag. We haven't changed any other tags in this repo. And so now if I did an artifact list command, this registry doesn't have any of the stuff we've been adding. So if I say, give me all the artifacts that refer to that regctl mod container or regctl mod image, it's going to say there's nothing. It's an empty refers list, nothing out there. So no API, no example. Now let me throw something big at you. Before we've been looking at these nice little one-liners, this one gets a little bit long. And so when you look at this, what I'm doing down here, and in fact, let me see, can I put this up top? Yeah. I'm going to go through and say, do an artifact put with a media type that I'm going to define. So for the artifact type, I'm going to say, make it an example syft. And that's just because no one's really started picking these media types out yet, and I don't want to step on anybody's toes just yet. And I'm going to take those two files we created. So we created a cyclone DX JSON, we created an SPDX JSON. I'm going to give each of those files their media type. And so I'm going to push this up as an artifact with two files in it. And then I'm going to send an annotation on the artifact itself, said that this was created by syft and it was created on, I'm going to give it the date of right now. And I'm going to say, I'm shipping this artifact up to the registry, but I'm going to tell it that this artifact refers to my local image. So this was that mod image that we were just working with. So if I run this, it goes super quick. I could have also done even easier than that. I can just say like an echo hello world. So if I did something like that, that would look just like this, where I can just push something up to a registry, echo hello world. It refers to my image, and I can add an annotation on there just to make it easier to find out of the list. So now if I said, do a list of my artifacts, now we're actually going to see these artifacts. This is what OCI created, was the way we can do this. We can now get our artifact listing out from the registry with the annotation. We can see that it's got this artifact type. That was that example syft that we just defined as artifact type. So now when we're looking through this list, we can say, hey, I'm looking for the SBOM from syft. Looking through this list, I can find it real quick. I know where it is. And in fact, if I run this, run my artifact get command, I've put all those filters into the get command itself. So I can say, give me the artifact that has that message greeting, and just return that, show me what that is. And I'm saying that from the refers. So I'm saying look for any artifact that refers to this image and pull that one artifact out of the list. And so when I do that, boom, I got my little hello OCI output there where I can look at that. But the example we were showing here with the SBOM was a lot more complicated than that. So let me clear the screen. The SBOM example, if I try to get an artifact instead of putting an artifact, I've got the filter that I want to put on the artifact type itself, where I'm saying, give me the example syft artifact. And then from that, find the media type of the file that says you're the syft spdx media type on that one. And then again, making sure that I'm looking at the refers list there. And when I do this, boom, I've got my SBOM. So now I've packaged together, associated with my image, the SBOM, any other metadata I want to. And if I look at this, this registry doesn't have, so if I just say, do my tag listing command here again, I run that, I'm going to see that now I've got this funny looking tag out there. And that is our image that we had to push, our index we had to push so that we can examine that. So if I was to query this thing and it said, regctl for this tag, and instead of doing a tag list, I can tell I'm going off script because I'm actually typing here. But if I said manifest get on that, it's going to tell me, hey, that should look really familiar, right? That was our artifact listing we were just looking at. More importantly, if I was to pull back just this one descriptor here, just this one entry, this was the syft one. Manifest get, I'm going to say, actually, give me the format and the body format. That's going to show me the raw JSON. And let me query this thing. Definitely going off script, so we'll see if this works. And what we see is, again, since I've gone through JQ on this, hopefully the colors aren't too bad for you. We got the config media type up there. We've got 2 layers. And these 2 layers, and I'm apologizing in advance for all the colors. In fact, let me see if I can run it through just like, yeah, there we go. That's easier to read. Got the config up there, and that's our example syft media types. That's how we pull this media type up to our listing. We've got a couple annotations, so we pull those up to our listing as well. So this is the kind of data when we build that index, we pull this data up. But we've got these 2 layers out there as well. And so each layer has its own, it's saying, hey, I use this file, I use that file. But more importantly, each one has its own media type. So I can say, grab the one for SPDX versus the one here for CycloneDX. And this is the magic of what we made. We made this refers field that says this SBOM right here refers to this other image out there. And this other image was that mod image we created. And so that's how we created this relationship between the 2 things. So this was kind of the huge magic of what OCI has been working on for a while, was trying to say, how can we associate these things together? And just getting the group to agree to, okay, this is how we're going to do it. This is the standard we're going to create. Now that we've got this, everybody can go out there and start building tooling around it. And that's what I'm really looking forward to, is when we get to the point that people can say, great, I was just doing this with a whole bunch of regctl commands. It would be awesome if syft, all the other tools out there, right, pick a SBOM generator of your choice. When it scans an image, don't output it to a local file system, just update it right there on the registry, right adjacent to the image. So getting these tools to talk to the registry, and then getting all the other tools out there, like your mission controllers you're talking about, like all these other applications that are trying to figure out how can we work with our image and do our mission control on the image, can now go up and say, I know where the things are supposed to be. It's supposed to be up here in this location. Let me find it, query it in a standard way. We've got the method in there to make these standards now. So that's what's been big coming out of OCI recently. How's that so far? I went off script, so I'm out of demo stuff here, but I'm more than happy to jump around on the command line if people have questions on this.
Wonderful, wonderful. I really like the demo. There are so many questions during the I have in mind, but all those answers in. And I see some of the people saying in the comments that how can we get the size of an image before pulling in using the regctl? So I think an answer is also in the chat that you have a dash format body command in
Yeah,
the
the format command does a lot of this. So if I did the localhost 5000 regclient regctl, and I'm going to pick the Alpine because it's a little bit bigger. If I did the manifest kit on that one, you're going to see that it doesn't have a lot of data in there. Let's say, hey, here are all the manifests. But if I pulled it for one platform, and I said, let me get the one for Linux AMD 64, And the top of this, it's going to actually sum up the sizes because that size was in each one of these descriptors there. It's going to sum up all of these sizes here. And the pretty formatting of this thing is just going to take all those numbers and it's going to total it up and put it up top. So you can see for any one manifest, before you pull it down, you know the size of all the layers within that manifest. That's if you don't change the formatting. If you change the formatting to say, just show me the original, this is what's coming out of the registry itself. So for the syntax highlighting, these sizes are in here. They're not the human format, so you got to change those numbers and figure out, okay, that's number of bytes and then convert it around. And then you have to sum it up yourself. And so that's the pretty formatting does a little bit of that for you.
Also, and one question that is already is on my mind, that we see a lot of Docker extensions in place. Do we see a regclient Docker extension?
So regclient can be a command line extension if you want to. The challenge I'm running into is Docker said they're going to start phasing that out. And so when they started saying they're going to deprecate that, I was like, shucks, that's going to take that pathway. I haven't done as much with desktop extensions. And so that would be kind of future on the list to figure out, is there a use case that people can see for a desktop extension, or does it make sense just to let people run it from the command line?
So I see a lot of, like, one of the things, like in this format, we can see the sizes of the images. One of the recent Docker extension we see in the market that can tell you the size of the images can reduce it. You can't pull the you can't pull the images that are so much polluted in size. So I can see on that angle. So if that storage client is available, if you think if it's available as a Docker extensions, what are the different use cases we can use this in different scenarios?
Yeah. And there are a bunch of commands in here that people can run to do different stuff. If you look at the help there, we've got commands for the artifact pulling and pushing blobs out there. A lot of the image commands, you've probably seen a little bit of this running out there. Manifest, if I want to query the individual tag, you see me do the tag listing. If I go through and just look at the image though, but the biggest one here is that people want to see, they want to copy an image from A to B. And so that's been the biggest use case I've seen. Because it's not only that I'm copying an image from one registry to another that we saw. I can say regctl image copy. And grab the. Now, if I wanted to, I can put this on my local machine. I can do this. I'm gonna run this command. It's going to copy a whole bunch of layers down there. It's now all showing up. Now, from this, first off, I've got all the, I'm in my presentation folder right now. I've got this directory called regctl now. So now if I say ls regctl, this just got created. This is an OCI format. So I mentioned we're going to sneakernet this data across. If I say regctl, we've got the tag that we just copied across. So I just copied across the Alpine tag and I just called it latest because I didn't give it a tag. If I had given it a tag, it would have been a little bit easier. And so I could have done that as well. I said Alpine right there. Now the command's going to be super quick because that's all the layers already there. It already had all the pieces. Now if I say do a tag ls, now I got them both sitting there. So we've got the way that we can move these things around on the file system. And I can just take this file system, ship it across, copy it from one place to another, expand out across the other side of sneakernet. So I've seen this used in different environments as well.
Yes, and also one other command, like can we have a regclient cache command, like when you pull the images from the Docker hub or the registry, but we have this is available on the local registry, don't pull that up in the, do we have those kind of capability in the regclient?
That is what it does so well. Because one of the things when you do that image copying, you're copying from one registry to another. I've looked at this as something that you might want to use within ephemeral instances in a CI pipeline. Because when you're in a CI pipeline and all those ephemeral instances are spinning up, every time you start up, you don't have the cache from the previous time you're running, or unless you want to pull in the whole file system. So if you say Docker pull, it's going to pull all those layers fresh again because it doesn't have it from the last time you ran. If you're copying between one registry to another, you know all the blobs that make up the manifest on the source registry, and you can query the target registry and say, do you have these blobs already? Do I need to copy you or not? And so when I was running that command to say, let me copy this from A to B, let me say Alpine 2, throw this thing into debug mode. And what you'll see in there is it's saying, hey, I'm querying this thing. It's actually doing a check to see, does that manifest already exist? If it did, it just skipped all those copy commands. So you start to see a bunch of detail in there. Blob copy skipped, it already was there. All the different pieces in there, it just said, I've already got it, I don't need to do it again. And so when you think about what you're looking at with an ephemeral builder, we don't need to every single time do that copy of all those pieces over and over and over again when the data is already there. And so it's very intelligent about saying, I've already got this data. It doesn't even have to fetch the manifest from the source registry. It can just query the manifest from a, it's called a head API call. And so one of these things in there, you're looking at image rate limit. If I say that on any image out there, so Alpine or something like that, it's going to tell me, hey, I've got four polls I've run and 196 left in my rate limit when I'm talking to Docker Hub. I'm trying to be very efficient in how many polls I do and how many actual fetches I do from the registry. And so it is checking and making sure, just run a head request, see if that already exists. Yes, it already exists. Okay, I can skip all the other steps in here.
Yes, that's super important for the real limiting. I can discover this command today. It's been very helpful for the people because we have a rate limiting in place and we need to ensure how many left, how many we hit the request. So that's great enough. And also on the topic of the OCI, previous I see the OCI principles are standard operations, content agnostic, infrastructure agnostic, design for automation, and industrial grade delivery. Anything, any other principle added as of today into the OCI, or these principles staying the same, or making sure these are mostly around the cloud agnostic, infrastructure agnostic, content agnostic, and infrastructure agnostic?
Yeah, they're really sensitive on making sure that they're not picking favorites, that they're not choosing and saying, hey, we're the standard for how Docker has defined it for us. They really want to say they are the community standard out there. And so when we added this new spec, it wasn't just us saying, okay, we created this, we're going to push it forward, it's going to be the OCI thing. And, Brandon out here from, the box boat working under IBM is going to be the one that's driving all this stuff out. It was very much a collaboration. We were driving, a bunch of different groups out there saying, how is this going to work on AWS? How is this going to work on Azure? How is it going to work for all these other cloud registries out there? We had Docker coming in and saying, hey, the path you're going doesn't look right to us. We want to see these changes in there. So it was very much a collaboration of getting all those different groups together to agree that this is the path we wanted to take that would look best, that will work on all the different registries out there and clients.
And yes, absolutely. And one more question, like in the cloud, we have Azure, GCR, ACR, and these other registries available. And these are the paid registries to be sure. And do you plan in the future to have those kind of visibility, like telling people like how much like people are pulling the images, how much cost is paying you? Do you see in the future tools like doing these kind, or you have those? Do you think about regclient has those features available in the near future?
If they're working off of a standard API that I can pick up that's under the registry API, absolutely. What OCI added recently was a way that everything in the OCI, when it's doing the queries, it's all under a specific path. It's under like the v2/ and this path that goes down into the repository. So all these calls out there are defined within the OCI. They specified recently, here is how you can extend that structure in there, that path structure, in a way that is going to work for your registry without ever possibly being trampled on by any other OCI extension in the future. And so they defined a structure for how people can define, here is my extension for Azure, for ECR, for pick your registry of choice out there. And so each one of those registries can go out and say, we're going to make our extension for some of our fields, and then know that no one's going to step on it. But it's under that same registry API structure so that they can work with all the other API calls that are out there.
Absolutely. And the last question I would to talk about, like, can you explain to the people, like, I had this question a lot. What is a build information and why do we care about build information today? What I can see is can use this build information for the policy engine to tell not do these kind of stuff in their production environment. Anything other use case you can think?
We've started seeing some of the build information come out from like the Docker build kit where they'll export and say, here's all the metadata about what we've run. And it gets to be really nice when you start to look at reproducibility and when you want to get into some auditing to say, hey, I've built this image and let me make sure nobody put something bad in there. Well, you've got digests for all the different inputs, and so you can start to validate here's what came in to build my image. And like I say, I've been working on some of that for the reproducibility on my side as well. But now with some of the stuff that OCI has added for the artifacts, you can just take that information and now ship that up as an artifact next to your image as well. So now when you ship the image around, not only do you have the signature of the SBOM, you've now got all that metadata from the build server itself saying, here's how I built the image. It becomes a nice way that you can do a little bit of extra auditing and a little extra verification of what went into that image.
Yes, and last question. Like we see in the Flux CD, in the I think version 0.33, and you also spoke about this during the presentation. Can you tell people like what this feature in the Flux is? And we see in the lot of the cloud native ecosystem, more and more these OCI formats are incorporated. And why do you think it's happening? Is it going with a good direction, or what do you feel about it?
Yeah, a long time ago, I was making, not too long ago, I was working with a project that had a half dozen, 2 dozen microservices out there. And so they were doing their builds and they were fanning all these microservices in to do one massive deploy out to production. And the process involved building the image for each one of the individual pipelines and then doing a git checkout from like some kind of GitOps repo, making a change and do a git commit to push that change into there. So that meant they had to have the git credentials and some of those things to be able to do that change in there. So I very much see when Flux did their announcement that would have changed how I designed that to say, instead of having to have the git credentials to do a checkout, to do a modification of what the new state is, to say, I'm building this version of this app, packaging this version, this one microservice, bumping that up. But the overall collection of all the microservices together is in that same repo. To be able to say, instead of doing it in Git to have it in OCI where I've already got access to push my image, now I just push up the new state up there as well. It felt like it was a much better model for the access that I wanted to give my CI pipelines, where I don't want to have to add in the access for the CI pipeline to be able to modify that Git repo.
Last question for the audience is Kumar Anurag saying, where to go if I want to learn more apart from repeating this session? That's a very good question, I guess.
Yeah, OCI itself has a lot of repos out there, and we've been doing a bunch of pull requests for that. We've also got on regclient, the regclient/regclient out there, so you can go up to that part. I've done a couple presentations on different pieces out there, so you can look at my presentation repo, and the presentation I was giving today, I'll have that pushed up as well. And so, yeah, handful of places out there. Otherwise, when we're getting into some of these low-level weeds, it's almost you're getting into specs. And so the people that really want to learn about this stuff are the people that are building the tools. And so the ones we need to communicate with are the tool authors, the ones like the syft author or something like that, to update their tool to start change things, or something like Cosign to update their tool to build their signatures slightly differently. And then it's going to be up to users to pressure them and say, hey, we want to use this new stuff. Let's get that standard out there. Let's get that updated with the new design for how we're going to start shipping this metadata around with the image. So yeah, how much do you just need to learn about it? I think a good chunk of it is just to say, just be aware of this and to know what the capability is, and then start pushing the tools to start exposing that capability to you if you need it. Uh-oh, might have lost video on you, so hopefully I'm still up. There we
Okay.
go.
Okay. Wonderful, wonderful. Thank you very much for explaining all this wonderful question as well. But I think for me, at least, the go-to place to run OCI Open Container Initiative is the KubeCon talk, because these are the wonderful talk given by the industrial leaders like Phil Estes and other people from IBM side and have the container lead. And there are so many good talks available. I think that's a wonderful place to learn more about it. And
Yeah.
one last question: are you going to the KubeCon?
Sadly, my talk didn't get accepted. But the other person I was going to mention, I think, has been like Jason, maybe Josh as well. But Jason's been on a bunch of these things where they've given some really good talks about things that they've done with the container registry. And so I think it's maybe Registries After Dark or something like that with some of their talks previously. Go check those out. They've got some really good ones out there of talks that they've given to KubeCon. And so when mine gets accepted, I'll be more than happy to jump up there and get a talk recorded as well.
Yes, absolutely, absolutely. I think that's a wonderful session for everybody learning to regclient as well. It's a GitHub repo. You can see the link on the screen and you start learning about it because we can for today we see all of the cool features today. And now it's been I try to spend more and more my time upcoming time in the regclient as well. So thank you, Brendan, having a wonderful talk with you today, and we'll have to catch up with you again in the future as well. Thank you very much for joining me on the podcast. Stay safe, stay healthy. Bye bye, everyone.
Take care. Thanks.